Let the fun begin! Oh my God! It's day 4. And it's starting. It's almost there. Day 5 is proofs. Don't miss day 5. That would be on Tuesday. But day 4 is going to be fun. Tangent theta. We got to remember a few tangs, kids. We got to remember that tangent theta is sine x over cosine x. We got to remember cotangent theta is cosine x over sine x. We got to remember cosecant theta is 1 over sine x. And this is 1 over cosine x. Now, if you're really struggling with that stuff, where have you been for the last month? We've been crushing this for the last month. If you don't know sine squared plus cosine squared theta equals 1, huh? Tangent squared theta plus 1 is equal to secant squared x, and this is equal to cosecant squared x. Commit these to memory. You got 2 new ones. Just these 2 are your new ones. Everything else is old school. All right. So here's how we're going to do this. We're going to express in terms of a constant or a single function. So we're either going to get down to just a plain old number or one function. So let's start. I don't know, I'm going to do random problems, but so cotangent squared theta plus 1, well, that's easy. That's just secant squared x. Now, I know that based on that information, but I also know that secant squared x is really 1 cotangent squared theta plus 1. So this is 1 minus cotangent, that looks sloppy, cotangent squared theta, or in this case x, plus 1. All right, well, we'll distribute the negative. So I get 1 minus cotangent squared x minus 1. These cancel, so I'm left with cotangent squared x. This is one you were supposed to have committed to memory, that sine squared theta, 1 minus sine squared theta is equal to cosine squared x. So far, not so bad. Let me do one of these over here. Let's just do this one. Show you how these are done. Cosecant. Okay, that's 1 over sine theta, or sine x, times. Tangent is sine x over cosine x times cosine x over 1. All right. You notice there's no equal sign, so I'm not going to put an equal sign. This is an expression, not an equation. The sine x's cancel. The cosine x's cancel. And I'm left with 1. That whole thing just became a 1. All right, let me do this one right here. I'll do 7 and 8. So let's look at 7 real quick. Let's see. I'm going to replace this. Remember I said you have to replace double angles? I'm going to replace this double angle with something that's sort of meaningful. And I am going to replace it with, let's see, probably the one with just cosine in it. 2 cosine squared x minus 1. I do that every time. So I'm going to replace this with 2 cosine squared x minus 1. Well, let me distribute that negative, so I get cosine squared theta minus 2 cosine squared theta. I should be using, oh, it is theta. Theta plus 1. Okay. Well, this is negative cosine squared theta plus 1. Or another way to write this is it's 1 minus cosine squared x. Well, I know that that is equivalent to sine squared x. So there's my answer. Oh my God, it's so much fun. And I should have been using theta. I don't know why I switched from theta. Sometimes it's difficult to remember theta. All right, let's move to the next problem. Let's check out 9. 9. So remember what I said. You have to replace double angles. We don't have a choice. You have to replace those. So this is sine of x, cosine of x, plus 2 sine x, cosine x. Well, that's just 3 sine x, cosine x. Oh, I forgot this problem was in there. That's a bad problem because it should have just one single fraction. And you really can't do anything else with that one, so that's about it for that one. Let's see. Cosecant theta. Now, I think I remember that cotangent squared theta plus 1 is equal to cosecant squared theta. So I can replace that. 1 minus cotangent squared theta plus 1. And I distribute. I'm not distributing the 1. I'm distributing the negative. So I get 1 minus cotangent squared theta minus 1. The minus 1's cancel, and I'm left with cotangent squared theta. All right, I'm going to do problem 13, but you should pause this, take a look at it, see if you can do it, and come back. I'm waiting. Go ahead and hit the pause button. No, just hit the pause button. Pause it. Oh, you're back. I'm sorry. Ooh, sorry. Didn't realize you guys got back so fast. Okay, so cosecant. Well, I know that's 1 over sine of x times. Sine of x is sine x over 1. And cotangent of x is cosine x over sine of x. Oh, well, these signs cancel. Oh, I'm just left with this, but this is really cotangent of x. So I should leave it as one function. And I'll be right back. Well, so far, so good. Not too bad. It is going to get a little trickier when you start to do these on your own. Again, I'm not the performing monkey. I am a teacher. So I'd like to teach you. So I'm going to teach you to hit the pause button. Find the two buttons that look something like this, and then hit it. Try the problem on your own, and then hit it again. And actually, when you hit it again, you'll hit this button, and it looks like the play button. So go ahead and hit the pause button now. Oh, you must have found the play button after you hit the pause button. You hit the play button, now you're back. Oh, good. Thanks for coming back. All right, so tangent theta is sine of x over cosine of x. Secant of x is 1 over cosine of x. And cosine of x is just cosine of x over 1. All right, let's see. This cancels with this. That's it? It's just this, which is really just tangent of theta, or tangent of x. All right, let's try this one. Whoa, 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 Nelly. Back up the crazy train. All right, so what do we have here? We have tangent on top. Well, tangent is sine of x over cosine of x. And secant on the bottom, which is 1 over cosine of x. I don't think I ever went through these rules with you up here. All right, cancel and rewrite. Well, whatever. I'll go through them in class. Basically, that's what I'm trying to do. You're going to try to figure... Your goal is to try to see if you got Pythagorean identities. What can I replace with what? What can I simplify? So on and so forth. Anytime you have a fraction divided by a fraction, you're going to flip and multiply. So we're going to end up multiplying by the reciprocal of this. So I'm going to multiply by cosine x over 1. Well, the cosine x's cancel, and I'm left with sine x. That's it. All right, so more fractions of crazy fraction stuff. So let's see what we got here. We've got sine x over 1 times 1 over cosine x all over sine x over cosine x. So let me see what this is equivalent to. So this is equivalent to, the numerator is equivalent to sine of x over cosine of x all over sine of x all over cosine of x. Now you can notice right away that the top and bottom are exactly the same, or we can flip and multiply by cosine x over sine of x, and notice that the cosines cancel, the sines cancel, and I'm left with just a big old 1. I'll be back. Okay, I'm back. Again, kids, while you're doing these problems, you should be trying them. I'm going to do that in class. I'm going to have you try them and then come back to me and try them and come back to me and come try them, come back to me. All right, so hit the pause button, try this problem, and then come back. Oh my gosh, thanks for coming back. All right, so we got to replace 2 theta, sine of 2 theta. Now, I can look at my formula sheet, and I know it's on there, or you can have it memorized that it's 2 sine theta cosine theta all over 2 cosine theta. All right, wow, that's fun. The cosine thetas cancel, the 2's cancel. I'm left with sine of theta. This stuff's kind of fun, isn't it? I think it's kind of fun. Now, I don't have any squared terms here, and I don't have any double angle terms here, so there's nothing I can replace. But I can double distribute, and I recognize this is the difference of perfect squares, so I'm going to multiply those together, 1 minus, and now I'm going to multiply these together, cosine squared x. Well, I don't have to do the outsides and insides. I know those are going to cancel, but I know that 1 minus cosine squared x is really sine squared x. That's one of those ones you have to have memorized, chillin'. 25. Once again, I don't have a squared term and I don't have a double angle, so there's nothing to replace. But I do see that I am squaring this parentheses, so I'm just going to write this twice. And I'm going to double distribute. Now, these are not difference of perfect squares, so I have to go through the whole thing. There's sine squared. Oh, this one's fun. I like this one. This one is minus 2 sine. Oh, I'm jumping the gun. Sorry. This one is, you'll see in a second why I meant to that. Minus sine x cosine x. Now let me distribute this one. This one is minus sine x cosine x. And then negative sine square, negative cosine times negative cosine is plus cosine x squared. All right. So now what I have is, now it's going to get fun. I have sine squared x minus, now these two can be put together, minus 2 sine x cosine x plus cosine squared x. Well, I remember a little thing called the Pythagorean Identity, which says that if I have, I don't know what just happened, if I have sine squared x plus cosine squared x, that's equal to 1. Well, that's what I have here. I have sine squared x plus cosine squared x. So those two can be combined to make 1 minus, now this is a double angle formula. Don't worry about the minus, but that's a double angle formula. That's sine of 2x. And so there is my answer, 1 minus sine of 2x. Come on, you're having fun. All right, let's see what we got here. Oh my goodness. Well, how am I going to do this? The easiest way to do this is to find a common denominator. Put this over 1. My common denominator would be cosine b. So I get cosine b. I'm going to show you two different ways to do this problem, just so you know that you don't have to always do it the same way. Sine squared b. Nothing to change there. But if I change the denominator here to cosine b, I got to replace the numerator, and I got to multiply the denominator by cosine b, and I got to multiply the numerator by cosine b. By the way, that's a beta. So cosine squared b. So what I end up with is sine squared beta plus cosine squared beta all over cosine beta. Well, we just talked about the fact that cosine squared plus sine squared is really just 1. So that numerator is 1 over cosine b, but that's really equal to secant of b. So there's your answer. Now let's do it a different way. Since I have a squared, I could replace it. So if I replace that, I end up with 1 minus cosine squared b all over cosine b plus cosine b beta. Now this here can be broken up. I can break this up into 1 over cosine b minus cosine squared b over cosine b plus cosine b. Because if I wanted to, if I put these together, they have a common denominator. We just add the numerators. Well, now why would I do that? Well, this cancels with one of these. So I end up with, isn't this secant? Yeah, this is secant. So this is secant beta minus cosine beta plus cosine beta. Well, the cosine betas cancel, and I end up with secant beta. Oh my God, so much fun. All right, so let's see. Right now, I don't really like changing things that are cosine and sine. I like keeping them the same. So I'm going to rewrite this as 2 sine squared alpha over 1 all over sine of alpha over cosine of a, whatever. Now, the reason I do that is because I like sines and cosines. They're nice. They're nice. So I'm going to multiply by the reciprocal. So I'm going to flip this, and I'm going to not divide by it, but I'm going to multiply by its reciprocal, which is cosine A over sine A. Well, this sine cancels with one of those, and it leaves me 2 sine A cosine A. Well, what is 2 sine A cosine A? Oh, yeah, that's sine of 2A. All right, let me pause. Actually, I think that's it. Let me see what's going on the next page. Yeah, I'll probably leave that as a little bonus for you. Okay, that's it. That's all she wrote. All right, the rest of them are yours, kids. Good luck. Play around with it. You have to mess around with it. You have to get frustrated. You have to try the problems on your own. All right? Good luck, kids. Bye.